Hi, my name is Noah Gift. I'm speaking with a couple other developers at Linden Lab. This doesn't represent anything to do with Linden Lab at all, but we just happen to work at Linden Lab. Our talk's going to be on the game industry and how Erlang fits into the gaming industry. One of the cool things about this talk is that there's going to be 3 people talking, and so it's a 3-in-1 special. If one of us is really bad, like maybe I'm already bad, there'll be 2 other people and one of them might be good. So that's and a little bit of the kind of the table contents here. I'm going to talk about just how we're able to use Erlang in a company and what other game companies or other companies might want to do in order to advocate Erlang in their company. Mario is going to talk about how he's used RabbitMQ in one of our products. And James is going to talk about how he's done Erlang development inside of a game that's in the iOS platform. So the first thing I want to start off with is that I know a lot of people say you can't get fired by using some technology. You absolutely could get fired by using Erlang. So let's just get that out of the way. I mean, a lot of times people, and I've had this at a couple companies, that they'll say Erlang's functional, it's complicated, regular programmers wouldn't understand how to use it, pattern matching is very complex, and I think that's a typical argument I've heard. I've also heard people say it's just much too complicated. Another reason why, if you're trying to get Erlang into your company, that they may not want to use it is that it's not Java, it's not Python, it's not Ruby, it's not C++. One of the things that's really surprising is that I've been programming in Python since 2000, so it's like 13 years. And I remember when people said that about Python. It was like, oh, Python, oh, it's this evil, it's a scripting language. And I think some of the same things I think people will say about Erlang. The other one too is that your boss might be an idiot. And I think a lot of times people aren't like truthful about that, and like you may just have a dumb boss, and or your boss can't code, and if you report to somebody that doesn't write software, they just don't get some of these things. Like the nuance is lost on them, and so if these are some of the situations, then you might actually be fired. So, but the good thing is that you potentially can just get a job somewhere else where there's actually a smart boss and you can work on interesting things. And one of the other things is that if you've kind of gone down the point where you've wanted to kind of fully commit to using Erlang, and you think you can get it moved into your company, I think the number one red flag that somebody that's competent in management would have is that your first day of the job, you say, I'm going to write the billing system in Haskell. I think you've then labeled yourself as potentially somebody who is just bringing out all these weird ideas, and that you can't be trusted to get things done. And so I think this is actually a really weird strategy that I think is a good strategy for lots of things in life. But if you want to get Erlang in your company and you're a, Java programmer and it's day one, or you're a Ruby programmer, I think if you show up early, you stay late, you underpromise and you overdeliver, you do that for 3 or 4 projects, people will trust you, and you could say, hey, this next project, we're going to do it in Erlang. So it's kind of weird that actually being really good at your job in some other language potentially is the reason that you could get the chance to use Erlang in a company. But I just like to strongly point out that that's, I think, a really effective strategy. One of the other things that's really interesting in having lived in the scripting world for quite some time is that if you get into interesting problems like distributed computing, a lot of times you have to deal with an event loop, and there's all this talk about how event loops are great, and you can handle thousands of requests a second. And I've had this issue with Ruby, I've had it with Python, I've had it with Node, where you write this thing, like at a previous company we wrote a syslog-ng clone in Twisted in Python, and I think it was like 7,000 requests a second, like awesome, right? And what's great about that is that you then install that event loop on a EC2 instance, and that EC2 instance has 4 cores, and then that EC2 instance starts to heat up, and all of a sudden you then go, boy, I think I actually need like 4 event loops because we're spending all this money on the server and 3 of the cores are just going to waste. And then I also need to make sure that I can easily distribute the load across all the nodes in the system. And I think this is the thing that is really why scripting languages are potentially not the right tool for distributed computing. Is that is a very tough job. It's not impossible. People do it, but you kind of get yourself into this state where you've solved this fairly complex problem by writing an event loop that handles thousands of requests a second, but then you've now got this other problem, which is that they all need to talk to all the other nodes in your system, and you would like to efficiently use all the cores, and it's tough. And one of the things that was really funny is that I was looking at Guido, the guy that wrote Python's keynote speech for the PyCon conference, and what was really fascinating about it was that they were talking about that they're doing a lot of the async, they're building in async into the Python language. And I think it's great. I mean, Python's a great language, Ruby's a great language. And what's kind of interesting is then I looked through some of the slides and it said async multiprocessing TBD. And I think that's one of the things that's like kind of fascinating about that is if you've done this now at like multiple companies and multiple languages, like TBD, that's the real world like distributed computing problem. Like so basically for real world distributed computing problems, TBD. And I mean that's fair enough. I mean but I think that right there is why you potentially should look at Erlang in your company, is that it isn't TBD, right? Like that's what it does. It does like distributed computing. And this is kind of what I was talking about before, is that once you get into these problems in these scripting languages, it really prevents a challenge because it is a very complex problem to solve. Another really interesting fact in this whole why to use Erlang versus a scripting language for a distributed computing problem is also energy efficiency. And I don't know how many people have been following things like carbon footprint and high mileage cars, but another issue is that if you have this same event loop and you've now virtualized, because virtualizing saves energy, and you have a 4-core box that you've rented from Amazon, and you have this one processor running hot, and then the 3 cores are doing nothing, you're basically using up all of this energy and you're contributing to global warming. You're increasing the carbon footprint of a server, and it's not necessary. And I think that's a really interesting thing that I've not heard many people talk about, but it's a real problem. Actually, this kind of brings me into the next slide, where one of the really interesting things about this, the whole event loop thing is that a lot of these talks that you'll hear at a conference, they'll talk about the world's biggest X, right? World's biggest Django, or world's biggest Rails server. One of the really interesting things about it is that there's always this secret ingredient, and I challenge anyone to like look back at this. If you look at the world's biggest whatever scripting language, there's a very strong possibility, if you look inside there, that Erlang is actually the secret ingredient that no one is talking about. They're using Celery, or they're using in Python, or they're using Event Machine that also talks to RabbitMQ. And I think this is kind of one of those really fascinating things that scripting languages kind of punt around, is that there are really hard problems, and the really hard problems are not actually being solved in that language. The really hard problems are being solved by using something that someone wrote in Erlang and then forklifted into the data center when the project was potentially failed. And I think I would be curious about some of these really big sites, to hear the backstory about when they actually introduced, RabbitMQ into the system and like what happened. And to give you an example, I know from a reputable source that one of these big sites, they did a profile where they looked at all of the CPU usage of one of these giant, world's biggest data centers, and there was a 6% utilization of the CPU. across the farm of servers they had. And so if you kind of look at that, and from the world's biggest website uses 6% of the CPU on I don't know how many machines they had, and that seems on the surface a problem. And not that any of these languages are bad languages, but it's just something to think about when you're building something big. When you're building something small, maybe it doesn't matter. So that brings me to the end of my section. I'm going to now hand it off to Mario, who's going to talk about kind of the real world, how we took and forklifted Erlang into one of our projects and saved it.
Okay, so my name is Mario Izquierdo. Thanks, Noah, for this introduction. And I'm not really an Erlang developer. I'm Ruby developer, especially JavaScript and all this fancy hipster stuff. And yeah, it's definitely easy to start in. You can write like very beautiful code. But then when you enter in the real code, it's like, oh man, we've been developing for a year and we only support 30 concurrent users. What are we going to do? And then it's when we're going to start using this secret ingredient. So let's see how Erlang can help you, even if you don't code in Erlang. And that is what introduced us to, like, is this one example of other tools you can use, like maybe Amnesia or other things. But RabbitMQ is a very easy to use tool, and it's a huge abstraction that you can build on top, and is language agnostic. So you just use like an API. So this is what RabbitMQ is. I'm pretty sure some of you guys who knows what is RabbitMQ or use it. So yeah, I can go pretty quick into this. So yeah, that's a need to explain this stuff. So well, just going very quick, it's a service for messaging that implements the AMQP protocol, and there are Erlang nodes running on Erlang application, so it must be good. And if you never, I know for a fact that most of Ruby people and Python people don't really understand what is Erlang. We always think, Erlang and RabbitMQ, we always think it's some kind of a queue system for messaging, or just for holding message in a queue and stuff like that for workers, but it's a lot more than that. So for us, an easy way to understand is like a service like MySQL, where you can open a connection, and you, instead of defining tables and indexes, you define exchange queues and bindings using that connection, and then you send and receive messages using those queues. So this is the first part of things that you can build on RabbitMQ, and it's about the queues and the consumers. So the consumers here will be your workers or your application. And the thing is that if you put multiple workers listening in the same queue, RabbitMQ will do automatically round robin. So you can use just the same queue and put in multiple workers listening, subscribe to that queue to do automatic load balancing. This is a simple one. It's not like a big algorithm, but most of the time it just works. Then the exchanges and the producers, those are other processes. And whenever they talk to RabbitMQ, sending messages, publishing messages, they are called producers. So basically, in RabbitMQ, you publish to exchange. You just define some exchanges. They are like outbox for sending messages. And then finally, you define your routings that connect the exchange with the queues. And bindings have like different rules, so you can build a routing system into this. You can send a message that gets delivered to this queue, and then it gets load balanced with different consumers or different routing. So this gives like a very, very flexible scheme to build your messaging system, and that supports a lot of different possibilities. And then the types of exchange and bindings, you basically, it has like 4, but I'm going to just describe 2. The direct exchange, you just have a message with a routing key, and you have different bindings with different routing keys, so the message gets delivered to this queue, and then this queue can have multiple subscribers where round robin will be done. And the fan out is just multiplies the same message. This can be used for pub stuff, like Twitter style things, where you just publish to whoever is listening for it. And it's very well suited for real time sending and all these nice things. So typically you use RabbitMQ. You connect to RabbitMQ, define an exchange, and start publishing message to that exchange, or define a queue and its bindings, and then subscribe to the queue and start listening to whatever message came over there, add more consumers to the same queue, connect applications written in different language, and that is the best thing. And especially is good for things like send and forget. Like for example, when you have a login system that you asynchronously send messages to it, and RabbitMQ will handle it with the queues and stuff. and will be processed by your login system or whatever. So this is a real user example, and this is the project me and some other co-workers were working in the last year and a half, and we built this is live already, it's in the beta version, and it's a web application built on Ruby, but it's optimized to support multiplayer experience in real time, which is kind of a text-based experience, but still have, whenever someone enters in the room, someone picks an object, someone drops an object, you are all connected. So in the backend, it has the Rails application, but then it has the game server, which is like an MMO server where things are running in memory. And so we decided to build this in Ruby. It's probably not the best idea, but we started with that. Was quick to start. And so a place that is a world instance will run in memory on one of the available game servers. And that is where the scalability problems can start. So our architecture is basically a browser send HTTP request to Rails. Then we have connection servers that will push notifications to the browsers. And then we have game servers and the connection servers that needs to talk to each other constantly because the game server is the one that's running the logic in memory. And this is our architecture before RabbitMQ. So this is what we start building here. Just whatever we needed, we start adding there. Oh, we need this. We need like a connection server, and so we build this system. Then we need a game server over here. We build this system. Then we realize, okay, so we need to scale this up. So we have multiple instances of connection servers, and they can push notifications using HTML5 push event source in our case, but could be WebSockets as well. But then here is how basically works, is that the browsers will send an HTTP request that will go to a Rails server that will respond with the HTML, JavaScript, and all the stuff. Then browser will connect to one connection server, event source, to get like a connection back. So once it's connected is when you start receiving notifications in real time. And the connection server needs to say, okay, so this is the user 1 that wants to connect to world 1. And world 1 may be running in memory in one of those game servers or in none of them if it's still not boot up. So it's boot up on demand. So then we have like a DO broker that we call, that is the one that this connection server asks using this socket connection here. Hey, I want to connect this guy to this world. What is that world running? And the DO broker is smart, and he knows everything that's going on. And he says like, okay, he's running in this game server, and sends the identification, and he's saying, okay, so I connect to this one and start sending messages with this guy. Now the connection is open. And then here, the problem is that the DO broker also was homemade, and maybe it's not a good idea to build a homemade system that knows about everything that is going on. And basically, if he believes a word is running here and you have a problem and it's not working here, then you're screwed. Just messages start breaking. I think it's there, it's not. So this is what maybe you guys can identify a pattern in here, something that we've built without being conscient. And this is basically what we have built there. We have made a pentagram. We didn't realize, and we cast the devil on us. So at this point, we had a system that was out of control and couldn't scale. It was just too many connections and stuff. So this guy was messing around for a while. But this is what we always thought, like, okay, maybe we need to keep working on and keep improving this. Like, yeah, you know, the broker is not smart enough. He needs to synchronize, send like sync messages to the game servers, and every 5 seconds check if everything is right. So just, okay, the omnipresent and omnipotent broker will keep devil away. But that's never happened. There's always more and more problems. You keep reacting to these things. And you also have more problems. You have kind of a wizard in here that because these socket connections here were so complex, there was no way each time, I don't know, like from the Rails process, you want to send a message to a word. Let's say you change the word name and you want that word to change in real time. And we didn't know how. It was so impossible to get a connection open here, so hard. Then we have kind of a master game server here that you send the message in there, and this will talk to the database, and those guys receive just a mess. And if you want to put like another admin tool or whatever that is talking to it, just so hard. So yeah, this is what we build in here. And I don't say, we've been using, yeah, this is the pentagram anti-pattern. Just I want to make a note that now that I found it and I realized. So just to generalize, you guys, when you build a complex system with a lot of interdependencies and things that are connected to each other, you're going to catch the devil. You just have to identify that beforehand. And when this happens, you're going to have dependence on black magic. And this is not only for networking systems, it's also inside objects and inside whatever you do. You're going to have dependence on the priest, that I call this the guy that this is the only one that knows how this thing works. And probably he don't even know that. So it's just, you depend on the priest to like, oh yeah, we'll fix that. And then, yeah, multiple global aware gods, like you have a lot of systems, they all know about everything, and they are very smart, but they never work fine. They conflict with each other, just gods fight. So the only way of fixing this is fixing with science. Like, yeah, you have to study the problem, you have to talk to the priests and say like, guys, we cannot continue this way, and try to find the right tool for the right problem, which is, well, this is like a list of all the problems we have building that, you know, like, most of people think about me that I don't like RabbitMQ, but I like RabbitMQ. It's good. It's like an abstraction on top of sockets. It's for every language, and it has this kind of magical, continuous, persistent connection that never gets closed, and that is hard to manage. It's just for two systems solved from one to another. It's fun. It's fine. It's great. But if you start adding like here and there, you're going to build a pentagram. So it's hard to scale, too many sockets. And also, RabbitMQ has very bad support in Ruby and limited communications. Then the broker is too complex. That is our god. So it's better to remove this. And well, the solution, as you guys can imagine, this is the X ingredient here. Put it RabbitMQ in the middle of all, and just systems connect to him, define queues and exchange inside, and then talk to each other. But how can you model all these complex things? Like, for example, if a word is running over here, how can you route the message to the right game server? It's very easy. You just build a queue and create an exchange for words and bind based on the word ID. So then RabbitMQ will route immediately to the word, and the game server don't even need, I mean, whoever is publishing to that word, it doesn't even need to know in which game server it's running. It's just publishing there. Then it's a little more complex when the word is not running in any place. So we still thought we probably need like a fully aware broker that knew about everything to say, okay, this word is not running, we are going to decide where to run it. But we also found a way to solve this using routing. And it's basically the idea that every game server that has computing power can subscribe to another queue that is like, we call it like the non-loaded words queue. And so whenever someone tries to publish to a word, if the word is not available, then publish the same message to the non-loaded words. And then some game server will pick that up based on round robin. And that actually works very, very, very well. So yes, we start with this theme. We just remove all these things, like go to hell with all these guys. Now we have a new god. That is maybe a problem, because we still have a new piece of our system that everything depends on. Like if he goes hell, we all go hell. But, well, you now have to make a decision. Who would you prefer to worship? Like the RabbitMQ god, which is supported by a big community, widely used, has known practices, written in Erlang. Now the problem for us was like, okay, so every message will go through RabbitMQ. What happens when we have more than 1 million messages a minute? What happens when we have 10 million messages? Is this scaling? And yes, the answer is yes. This is built on Erlang. You can read 2, 3, or 4 nice books of how to scale it if you need to, how to spin nodes. And it's much better than depending on the arcane goals that were defined by some dudes in a reactive way, remove fears the people of their time, they keep adding stuff, and no one really knows how to scale that stuff. So that is a good choice, because RabbitMQ rocks. And Dio agrees with that. He's very happy with that decision. So now we have this advantage. Yeah, this is people is happy. Now we have consistency because MQP is going to be our protocol for messages. And new developer games is like, you don't know what is MQP, just read this website and we don't need to explain you how it goes. It's more flexible. There is this is a very, very important one. Visibility is actually, like before in the pentagram that we have, what happened is something goes wrong. Like one day, servers don't connect. Servers, they are down. The only solution here, time, right, 2 minutes, okay. The only solution we had there is that we have to kill a chicken and throw blood in the pentagram and run and start praising. Like maybe black magic will make this work. And the next day, like, systems are up again. That's awesome. And no one knew really why. So with RabbitMQ, you have a lot of different monitoring systems. And one of them is very nice, is web-based. And it can also draw, like, automatically draws a graph based on the exchanges, your queues, everything you have. You can see all the bindings. So it's like if something goes wrong, you just go there and look what is going on. Don't depend on that black magic. And there's less restrictions because now any system can talk. We don't have that Gandalf guy there. Just connect to it. Sure. More support, a lot more features, is routing. And this is very important one too. We don't need like a complex broker. And it has automatic load balancing for it. So this is what I explained before, but if you guys want to see real quick how the game message can go in RabbitMQ, those are the connection servers and the game servers. Each of them has a queue, and this purple thing is defined inside RabbitMQ. So if you have this avatar 1 and avatar 2, you have those bindings here. So whoever wants to talk to this avatar, it just needs to open a connection to RabbitMQ, publish a message to this avatar clients direct, and this is going to route us automatically here to the connection server, which we're going to push. And the same thing for worlds. This game server is running world 1. As soon as it's running it creates this binding. And from now on, you just send a message here, and just goes automatically to this world. And loading a world instance is a little more complex, is what I was talking about, of the non-loaded worlds fan out. And every game server that is available to support new traffic will subscribe to this queue. So let's see, for example, we have the avatar 4 that wants to play in world 2. And so as soon as this gets connected, this new binding is created here to be able to receive message. Then the message connect world is being sent to the world instance, but then RabbitMQ will bounce it back and say that, sorry, this world is not running. So what we do is send the same message to the non-loaded fan out, and this that has one single queue, and every single available game server will be subscribed to this one. So in round robin, we'll send to one random game server that we still need like a global lock, which is not nice, but booting worlds is not something you do constantly, so it's okay. You just lock it for avoiding race conditions, like maybe Avatar 5 also wants to check to world 2. And this was maybe the most complex thing. But once it's loaded, it creates a new binding here and responds back to the avatar's client that will go back to this. So they both don't need to know each other. They just send the expected message. And once this connect AC keys is received, then from this point, this connection server will send message to this world instance and will get routed to the right game server. And now the great thing is, for example, how do you make more complex load balancing? What happens if you have one game server that is overloaded with stuff? Do we still need a system that knows every game server and which one is loaded, which one is available? In reality, not. You can still make them self-aware, and just, for example, this guy gets busy, he just can't remove this subscription and say, I don't receive more words for now. And whenever he becomes available again, he just reconnects. So really, you can build your system being independent. And yeah, questions at the end. I'm gonna let my friend James go to the next part. And it's time for mic chance.
Right, so my name's James Mayfield. I work at Linden with the previous two speakers. And I was going to say, while Mario gave the perspective of someone who uses Erlang without using Erlang, I'm going to be sort of not only introducing you to the project that I work on at Linden Lab that uses Erlang directly, But also just from, I'm relatively new to the language. This is my first really relatively large project in Erlang, so it's sort of, there's that perspective as opposed to someone who doesn't use it at all.
Missing all the fun.
Yeah, that's right. So I'll start with introducing the product. It's called Versu. This, from the tagline, it's an interactive storytelling platform that builds experiences around characters and social interactions. That's really just sort of an elaborate way of saying a whole lot, actually. But more particularly, what the game is, it's sort of a text-based interactive fiction game that has it's a simulator underneath that drives these things. It's not a traditional sort of choose-your-own-adventure. These things are happening with each event that a user adds into it changes the next outcome. So there's a whole lot going on. So the components of Versu, there's a simulator, and that is written in C. It's written in C. One of the issues with it is because it's a long-running C process that, and because it consumes content that it's potentially written by users, there is that odd chance that bad things can happen, and we need to manage that. The other component is the sort of business logic layer, and that is written in Erlang, and it uses a port to talk to the C process. It maintains a lot of the state of what's going on. Actually, it sort of duplicates the state, kind of what's going on in the C process, just so we have some access to it. So it tracks the players in games that are playing in any given simulator. And also, it does some transformations of the data, the information that's flowing in and out of the simulator. Nothing really super complex, but there is that. And then, of course, there's the web application component of it. There actually, you see the trademark. It's supposed to be slightly sarcastic. It just got moved. So, because, you know, it's a web app. Anyway, so its job is to expose a slightly REST-like interface to the simulator functions underneath, and to expose the interface, or to drive the interface on top of it all, the user interface. The other component of it is we need some sort of data storage for things like saved games, and as I alluded to earlier, user-generated content. So those are the sort of primary, you know, the big swath components of the system. And now I'm going to sort of show you. So when I started at Linden Lab a little less than a year ago. I was brought in to sort of be the Erlang guy, taking over a project that was written by the guy who wrote the simulator. He sort of fleshed it out, did a prototype in Erlang, and I inherited it. It was roughly this, and these diagrams are incredibly simplified, but it was roughly this. We had a middle-teen web server component that talked to an Erlang process that had all of the logic for everything, and then inside that it spawned another process for that maintained the port that talked to the C simulator, and it was it worked really great as an instance of one. So this was an interesting thing at this is, this is, like I said, prototype code. I walk into it, my first really large Erlang project. From the perspective of someone new to it, it was wonderful to come in and look at this, you know, a somewhat sizable bit of code, but everything in nice little digestible functions. Didn't take me long at all to sort of digest what's going on, how the pieces were interacting with each other, and move on to sort of basically started moving towards an OTP design. I don't know why the simulator is red. I think that's more awesome formatting joy. However, so I moved it to a web component that seemed to be a bit more supported. So I chose Cowboy. And this was just the very first step. It was just, how can we make it to where things will restart should something really bad go wrong? And just created a little supervisor Now we have an Erlang process that's managed, and a simulator. The simulator interface really is just, it creates the port and does any sort of logic for consuming the inputs and outputs. So that was the just first step to try to sort of step into, I suppose, a more proper Erlang design. But from there, it didn't take much at all to move it to, so now we want to scale, right? We want to have more than one simulator. Each simulator can handle a certain number of games. So we wanted to move to how can we make use of all the cores on a machine, spawn multiple simulators and still route traffic accordingly. From that first step, it was real easy to move to something like this, where we have, everything's managed. We do have, so the simulator, because these states need to match the state of what's going on in the simulator, we built the supervision tree such that these guys can start and restore their state and completely independent of the simulator business. Whereas this guy crashes, this is one for all, and they all go down and restart. And it's less than ideal when you have more than one game on the simulator. These are future issues to resolve. However, we moved to this. It was really great. Now we can spin up however many instances of the simulator we want. Traffic gets routed accordingly. Everything works great. The next step then was to now let's just spin up multiple nodes. We can now create as many. It's the same deal, but just on a machine or in an Erlang node of however that manifests itself. Behind a load balancer, Cowboy on each of them. They can all consume requests, and everything just happens in an increased awesomeness sort of manner. And then to add for the storage component, we increased our awesomeness by using React, which works well for our needs, and it's wonderful in terms of being able to, again, scale out however we need there. Yeah. Oh, and in this case, so what we're doing is traffic comes in. There's can't remember what I was going to say. All right. It figures out which simulator a particular game. Everything's keyed off of a game ID. Figures out which simulator that's running on, and it uses RPC call to find whichever node's going to just get to where it needs to happen. Again, I think it's pretty straightforward, but it was great for me, having come from spending years of Python and otherwise, and some of these problems were a bit more challenging to implement. So my takeaway from having gone through this experience was that it makes developers happy when you have a really great, elegant way of expressing some of these potentially difficult things. It certainly made me happy. So even if we take away that S, it's true. Or perhaps only if we take away the S, it's true. I don't know. But I'm assuming that a lot of people are happy by using for the chance to get to use Erlang. And the operation, the ops guys love it. It's like we can produce this nice, here's our release. Here it is, just untar it and go. And everyone loves it. And adding more machines, taking down machines, everything happens with great joy. And personally, I like the fact that having taken my first big dive into Erlang, I'm realizing that there's all this incredible stuff. I've got so much to learn. It's part of the reason I'm here. Part of the reason I'm excited to move forward. Continuing to just to make sure that Erlang has a good presence in the company where I'm at. So that was my sort of quick dive through Erlang and a newbie's experience with it.
So we should do questions.
Mm-hmm.
For everyone, I guess. Yeah.
Mm-hmm.
I have a React question. How do you guys address? Do you do any map reduces or?
No, not at the moment. We're at a pretty early state. We haven't released user-generated content to the world. When we do that, we'll have some more complex needs for querying and whatnot. As it is now, it's really simple. It's just save games. So it's really easy to just do direct. We can always do to sort of key-based access.
But we also, due to the success of this project, we're then building another project where we're actually going to use some of the more advanced.
That's right.
React, like
That's right.
secondary.
Yeah, we're going to hopefully that. Okay.
Yes?
Hi. So I saw you guys use RabbitMQ rover in the first diagram where you show us the architecture of the level. So what were you guys using the RabbitMQ for at that time?
What was what?
In the old days.
In the old days, you were using RabbitMQ at least.
That's true.
So, I'll take this one. So at the very beginning, there was, I think the pentagram was the best description, there was a prototype that was written. And this is what you get into with like Ruby and Python often, is that you write this prototype and then you then run it on your laptop and then 4 people can use it. And what happened was, as we were trying to get it ready for launch, we saw some massive bottlenecks. It's one of the first things that we did before we did a complete re-architecture of it, was to take some of the chat function, basically take the chat functionality out and put it into RabbitMQ. And so this happens a lot at game companies, is that there's a lot of pressure to ship things quickly. And so you have to give these like kind of partial solutions where if you're working at like a more commercial software house, you would actually never have to do this. You would just, from the very beginning, design some system that would have scaled horizontally. With game companies or film studios, a lot of times you'll have some solution that's, you have to do incremental pieces. So it was basically, this was phase 1 of fixing all of the problems of what the original architecture was just to take some of the load off of the simulators that were event loops and to put some of that into RabbitMQ.
Right. So once you escape the RabbitMQ server for replacing your whole infrastructure to push some full messages, how did you guys make sure the system was coping with the message rate and therefore it was
I can take that one. So
load testing this?
yeah, you're asking about the transition was not that easy as in the diagram. Let's just take those guys away and replace with a nice thing, of course. So the strategy here was first learn more about RabbitMQ, because we were using it for chat for a while, and then once we kind of try to figure out how we could do this routing thing, and once we got there, we still need to validate if it would work. So we built a prototype that was basically one fake connection server and one fake game server, and they did like a fake logic and only send the message in the same format that was supposed. So that was built in 1 week, and after 1 week we had this prototype where we could be like a cloud of services. So we have like an instance of RabbitMQ, and each of us in our laptops could start a game server, a connection server, and they will connect automatically to RabbitMQ, start routing message. And once we saw that was working, it was like, oh, this is working wonderfully. Then we fixed some small things in that small prototype, but it was like 2 weeks, and we validated that the thing was working. And then we saw, how could we scale that? We look at the internet, okay, so the day we need this, we are gonna have an answer for that thing. And then was maybe 1-2 months moving the prototype, implementing it in our real system with a lot of small details, broken things. But yeah, at the end it worked, and maybe 1 month and a half, 2, we had the new system working. It was much better.
Is there something about the simulator that makes C a really good choice? You considered porting that to LS?
Right, I believe, so the guy who wrote it is Richard Evans. He's written simulators for The Sims and Black and White and so forth. So he wrote it. I think he did originally start down the path of writing it in Erlang. I think it just came down to performance issues, and he likes his C, and so he just wrote it in pure C. And actually, that's really helpful for us now because it sort of gives us a bit of portability. That gives us options. But yeah, so he shifted tracks and wrote it in C and with the sort of Erlang layer on top of it.
Yeah, because the other aspect of it is that there was this rapid prototype phase, and it was a web app, and then it turned into a mobile app. And the fact that it's in C, now it's actually going to be a completely native app. The fact that it's in C is actually a huge advantage, because then we can take the C and then just run it locally inside of an iOS runtime.
Mm-hmm.
Any other questions? We're just out of time. All right, thanks guys. That was really interesting. Appreciate it.
Thank you. Thank you.